Welcome back to the GCSE Maths Pro YouTube channel. In this video, we will be looking at the Edexcel June 2024 Paper 1 Higher Tier Past Paper. This is a non-calculator paper, so make sure that you've practiced answering all the questions, also without a calculator. Question 1. Here are the first four terms of an arithmetic sequence: 1, 5, 9, 13. Find an expression in terms of n for the nth term of this sequence for 2 marks. So an arithmetic sequence means there's the same difference every time, so I like to just work that out. You can see that that's 4 every time. That difference I like to put in front of n, so 4n. I then will write out the 4 times tables, so 4, 8, 12, 16, and all I have to do is figure out what do I need to add or subtract to get from the 4 times tables back to each of these terms in the original sequence. From 4 to 1, we take away 3. From 8 to 5, same thing again. Every time I have to take away 3. So therefore, my nth term is 4n minus 3. Question 2a, work out 3 4/5 minus 1 2/3. So when I add and subtract mixed numbers, I like to convert them both to improper fractions first. So 3 times the denominator 5 would be 15 plus 4. That would become 19 over 5. Take away 1 times 3 plus 2. 1 times 3 is 3, plus 2 is 5, so 5/3. Now I can go through with actually subtracting them, so I have to have a common denominator. The lowest common multiple of 5 and 3 is 15, so I must change both fractions first. The first one obviously multiply by 3, which is 57 over 15. Take away the second one, multiply by 5, 25 over 15. Now I can actually subtract the numerators, which gives me 32 over 15. They haven't actually specified how to leave your answer, so you could leave it as 32 over 15, or if you want to put it back into a mixed number, that would technically be 2 2/15. So either of these two answers would be fine for 2 marks. For part B, we have Kevin was asked to work out 2 1/3 multiplied by 5/8. Here is his working and his answer. They've told us that Kevin's answer is actually wrong. We need to write down what mistake Kevin has made for 1 mark. So having a look at the working out, if you're not always sure, you can also work it out yourself and then compare the answers. That's also a good technique. But let's have a look first. So he's obviously converted the first mixed number into an improper fraction. 2 times 3 would be 6, add 1 is 7, so yes, that's fine. He's then multiplied them. 7 times 5 is 35, and then 3 times 8 is 24, also correct. And then converting it back into a mixed number, this is where I would say the problem is, because 24 does go into 35 once, but the remainder is not 9, the remainder is actually 11. Normally I find it's easier to explain what it should have been or what he should have done instead of explaining what's wrong, so I would say should be 1 and 11 over 24, but as long as you refer to something around this point here that he has incorrectly converted back into a mixed number, that maybe it should be 11 instead of 9, that he's not got the numerator of his final answer correct, anything like that, any reference to this being the problem should be okay. So that in total for that whole question is 3 marks. Question 3. The diagram shows a plan of a floor. Petra is going to cover the floor with paint. Petra has 3 tins of paint. There are 2.5 litres of paint in each tin. Petra thinks 1 litre of paint will cover 10 metres squared of floor. Assuming Petra is correct, does she have enough paint to cover the floor? So it's not just a yes or a no question, we obviously have to work it out first and then at the end you say yes or no. So this is obviously the context of area. Let's work out the area of the floor. You can split it into 2 rectangles because it's a compound shape. So either across here or vertically, it's up to you. I'm going to go with across here. So for the top rectangle, I can see that the area is 5 times 10, isn't it? And then for the bottom shape, I would have to add that. I can see that I've got 6 as one of the sides, but I'm missing another side, so you'd have to work that out. I'm missing the vertical side, aren't I? But they have told me that this whole side here is 8, and this part is 5. So the missing bit must add up to 8 again, mustn't it? So that would be 3. And if you split the shape the other way, you can do the same thing, but horizontally. So 6 times 3 That gives me 68 meters squared. So the total area is 68 meters squared. We've been told that 1 litre of paint will cover 10 meters squared of floor. There are different ways or different orders that you can do this, but I'm going to look at now the fact that Petra has 3 tins of paint, and each of them have 2.5 litres in them. So the paint would be 3 times 2.5 litres to get the total litres, which is 7.5 litres. And then that 1 litre of paint will cover 10 meters squared of floor. So how many meters squared would that cover? We'll just multiply it by 10. That would be 75 meters squared of floor. So, does she have enough paint to cover the floor? Well, we need 68 meters squared worth. We've got 75. So yes. But therefore, yes, she does have enough. And as you can see, for part A, that is 4 marks. We've also got a part B, and it says, actually, 1 litre of paint will cover 11 meters squared of floor. Remember that previously she thought it would be 10 meters squared, so that's the difference, 11 instead of 10. Does this affect your answer to part A? You must give a reason for your answer. Does it affect our answer? Well, no, because we go back. We've already said that she has plenty. She already has enough paint to cover the floor, and now we've worked out that there's actually even more paint coverage in each litre, isn't it? We can cover more of the floor with each litre. So that's just more again, isn't it? So does that affect our answer? Well, no, because we already had enough in the first place. She already has enough paint, something along the lines of that. It doesn't have to be the whole 3 sentences there. Something to the same effect of that she will just end up with more paint left over, or you could actually calculate it if you want, but you don't have to. It's only 1 mark. Any version of no, it doesn't affect our answer, she already has enough. And that's therefore 5 marks in total for that question. Question 4, here is a Venn diagram. Write down the numbers that are in the set P apostrophe. So we need to know what that means. When you've got the apostrophe, it means not. So as in this case, not in P. So the whole of the P bubble, we're ignoring that. Anything in P, we want to ignore. So write down the numbers, so list them. 10, don't have to do it in order, but I'm going to try 11, 13, 14, 16 and 17. That's your first mark. Part B, a number is chosen at random from the universal set. So that just means from the whole Venn diagram. Find the probability that this number is in the set P union Q. So we need to memorize what this kind of U shape means. It means or P or Q. So where is that on our Venn diagram? If it's in P or Q, that's referring to both of the circles. So it's in either or, but now we want to know a probability. So I would count how many numbers are in P or Q, which is 5, and then out of how many numbers are in the whole Venn diagram. That would be 9. So 5 out of 9. And I would just leave it as a fraction. So you get 3 marks in total for that question. Question 5. Sophie drives a distance of 513 kilometres on a motorway in France. She pays 0.81 euros for every 10 kilometres she drives. Work out an estimate for the total amount that Sophie pays. So it's an estimate, right? Because this is a non-calculator, we're not going to actually use those exact figures because it would be just too difficult, wouldn't it? So you can round. I would normally round any of the numbers to one significant figure. In this case, we could round this to 500 kilometres. And then the euros, maybe just 0.8 euros. And then the 10 kilometres is fine, isn't it? So how much would she pay? Well, we need to work out how many lots of 10 kilometres she drives. So obviously 500 divided by 10. You see how that's so much easier now to work out? Is 50. And then, so therefore 50 lots of the 80 cents, I guess it is. Now, you might be okay to round that up to even maybe €1, but I would probably leave it like that because it's effectively just working out 80%, isn't it? Which isn't too difficult. 10% would be 5, so times that by 8 is 40 euros. Now, you do have to round at least one of the values, though. If you don't round any of it, you might lose a mark because it does say to estimate, and you haven't estimated if you've done it exactly. So I would round at least one of those numbers. They will also accept 40.5 euros if you did use the 0.81, but you rounded the 500, that's also fine. So 3 marks for that one. Part B, is your answer to Part A an underestimate or an overestimate, and we must give a reason? We'll have a look at how we rounded it. Yours might be slightly different to mine, but how did we round it? I rounded down the distance that they travelled. And I also rounded down, slightly, the money, didn't I? So, mine, in this case, would be an underestimate because actually Sophie drove a little bit further and it also cost a little bit more for every 10 kilometres. So for me, I would say an underestimate. And then literally just the most basic answer to say more specifically because I rounded the distance down, I rounded the price down, but just something to do with the fact that it's an underestimate because we rounded down. As I said, for these worded questions, they don't have to be full sentences, you don't have to give loads of detail, just think of the most obvious thing you can say because it's only 1 mark. So 4 marks in total there. Question 6, here is a straight line L on a grid. Find the equation for L. So the equation of a straight line is always in this format. Y equals mx plus c. So we just need to work out 2 values. M is the gradient, how steep is the line, and c is the y-intercept. Now normally I'd work out the gradient first, but in this case, because we can see it in front of us, the y-intercept is just there. Where does it cross the y-axis? Crosses at 3. So I can already write that in. Something x plus 3. Now the gradient obviously requires a bit more working, so what I like to do is choose 2 what I would call solid coordinates, so whole numbers, so really easy coordinates. So you could also use that 0, 3, might use this one here, 2, 6, and maybe this one here, if we could try, negative 2, 0. I wouldn't try and use, let's say for example, this one, because I don't know exactly what it is and I don't want to guess. So try and use whole numbers, and then we just want to do the change in y over the change in x. So vertically, can you see how we've gone up? By 6, we've gone up, haven't we? And then horizontally, we've gone across by 4. So for the gradient, we do the change in y, 6 over the change in x, 4. And I would probably just simplify that, which gives me 3 over 2. You can also write 1.5, but I wouldn't really bother with a decimal. So there we have y equals 3 over 2x plus 3. And that's 3 marks. M is a different straight line with equation y equals 5x. Write down the equation of a straight line parallel to M. So ignoring this one up here, it's not anything to do with part B. What do we know about parallel lines? They have the same gradient, which is the letter, as we just said, in front of the x. So any parallel line to M would also have to have a gradient of 5, so 5x, and then you just have to choose a different y-intercept. Currently, it goes through at 0, doesn't it? We could put plus 2. +1, -1, -5, anything like that. As long as your gradient is the same and you do choose a different y-intercept. So plus or minus any number after the 5x. And that is 4 marks in total for both of those parts. Question 7. Kasim has some small jars, some medium jars, and some large jars. He has a total of 400 jars. 3/8 of the 400 jars are empty. For the empty jars, the number of small jars to the number of medium jars is 3 to 4. The number of medium jars to the number of large jars is 1 to 2. Work out the percentage of Kasim's jars that are empty small jars. So we could work out how many are empty in the first place, couldn't we? I need to work out 3/8 of 400 without a calculator. That means I'm going to divide by the denominator and then multiply by the numerator. So you can use bus stop here, or what I would do is just do 40 divided by 8, I know is 5, add the 0, 50. And then times by 3 is 150. So there's 150 empty jars just generally of all sizes. And then within the empty jars, we've got these 2 separate ratios, but they do overlap with the medium jars. So what I might actually do is convert that into a 3-part ratio. Small, medium, large. So we've got 3 to 4, small to medium, and then 1 to 2, medium to large. So then I would just have to find the lowest common multiple of 4 and 1, which is obviously 4. So that first ratio can stay the same, 3 to 4. The second ratio, I would have to multiply it by 4, so that's 8. 3 to 4 to 8. Now, I'm just going to share out the ratio and find out the small side. So we normally add together the number of parts in the ratio, which is 15. We would then divide by how many jars that are empty, we have by 15, so that gives me 10. So that tells me that there's 10 empty jars per part of my ratio. Now, obviously I just want to know small, don't I? I don't really care about the rest of them. Small, there's 3 parts, so 3 times 10. 30. So now I've got the exact amount of small jars. The last thing I need to do is remember it is a percentage that they're asking for. So, what is 30 jars out of the original 400 as a percentage? So we do 30 out of 400 times 100 to make it a percentage. Now, here I'm just going to knock off zeros, 3 out of 40. So 3 out of 40 is still quite difficult to work out, so I think I'd probably use bus stop here if I didn't have, obviously, a calculator. So how many times does 40 go into 3? Obviously, none. Then I carry it over, I've got 30 here. How many times does 40 go into 30? Still none. Carry over the 30, it becomes 300. How many times does 40 go into 300? Well, that would be 7 times into 280. And then my leftover, my remainder, is then 20, so that becomes 200. How many times does 40 go into 200? 5, no remainder. So I've got 0.075, but that needs to be a percentage, so times it by 100. Just move the decimal place twice, gives me 7.5%. So however you want to work that out, as long as you do end up with 7.5 at the end, you might have done it differently to me, that's absolutely fine, as long as you've obviously got the correct figures here. And that one is 5 marks. Question 8. Len has 8 parcels. The mean weight of the 8 parcels is 2.5 kilos. The mean weight of 3 of the parcels is 2 kilos. Work out the mean weight of the other 5 parcels. So this is what I call reversing the mean. Think about how you worked out the mean, or how they might have worked out the mean. For the 8 parcels, they would have added up all of the individual weights for all 8. So we obviously don't know what they are individually, but the total weights for all 8, they would have added them up and they would have divided by how many there are, which is 8, equals 2.5. Do you see how then I end up with this formula? Effectively this equation, I guess, that I could reverse. So if I multiply across by 8, that will leave me with the total of all 8 parcels. So 8 times 2.5 is 20. So now I know that all 8 parcels weigh 20 kilos. I could do the same for the other 3. So the total for 3, you would have then divided by 3, is equal to 2. Reverse that. So the total weight for 3 parcels is 6 kilos. Do you see how now I could work out the total weight for the other 5 is just the difference between 20 and 6, isn't it? 20 minus 6 gives me 14 kilos. And now I want to work out the mean. Well, I would add them all together, which I know is now 14 kilos, and divide by how many there are, 5. You could do bus stop again here, or dividing by 5 is a little bit easier because you basically divide by 10 and then double it, or double it first and then divide by 10. So that will give me 2.8 kilos. So that's what I mean by reversing the mean. 3 marks. Question 9. In a sale, the normal price of a coat is reduced by R%. Given that the sale price is equal to 0.7 multiplied by the normal price, find the value of R. This is just multipliers. I think they call it multipliers. If we are going to reduce a normal price by a percentage, we would normally do 100% minus whatever we want to reduce it by. And then we would convert it into a decimal, which is where you divide by 100. And I know that that equals 0.7. Now you don't have to write it out like this, but I'm just writing it so you can see it in front of you. You could always obviously reverse this formula. You could try and solve it for R. But effectively I know that the reduction was 30%. Because to get this is basically 70% as a decimal, isn't it? And if I've reduced it and I'm left with 70%, then I know that I must have reduced it by 30%. So you only get 1 mark for 30. You don't need any working out here. You obviously can write some if you want. You don't have to write any working out because it's only 1 mark. But this formula here is to work out 70% of the normal price, which is therefore a 30% reduction, isn't it? Because the original normal price was 100 to start with. Question 10, solve the simultaneous equations. This is a nice question because it is just linear simultaneous equations. The only thing though is that we don't have either coefficient for x or y being the same. Normally for these I like to use the elimination method. You can also use the substitution method if you prefer. As long as we end up with the same answer, it shouldn't matter. So I'm going to use elimination, which means I need to either make the x's the same number or the y's the same number. Now, here they're both different, so it's really up to you which you prefer. I might make the y's the same just because they're smaller numbers, but it doesn't really make much of a difference, I don't think. So to make the y's the same, let's say that this is equation 1. What's the lowest common multiple of 3 and 2 is obviously 6, which means unfortunately I do have to change both equations. So equation 1, to make it 6y, I'd have to multiply by 3. And you do have to multiply the whole equation by 3. So that'd be 15x minus 6y equals, and then 3 times 23 is 69. Same with equation 2, but that one, to make it 6y, I'd have to multiply just by 2. So 4x minus 6y equals 36. So now I've got both the same y. I then have to work out, do I need to add or subtract the fractions? You might remember it as SSS or DSA, same sign subtract, different sign add. They're both negative, so that's the same sign, so I'm going to subtract. Now just be careful because we've got a few double negatives here. So 15x minus 4x is obviously 11x. And then here we've got negative 6y, take away negative 6y. That bit there is a double negative, so that's why it will obviously cancel out, that's the whole point. It should cancel out to make 0, there's no longer a y. 69 minus 36 is 33. Do you see how now I've got an equation with just x, so I can divide by 11, which gives me 3. So I now know that x is 3. Once you've solved for one letter, it's really easy to find out the other. Just choose one of the two original equations and sub your answer in. So sub x is equal to 3 into, now whichever you prefer, I might do equation 2 because it's smaller, into equation 2. So 2 times 3 minus 3y equals 18. That's obviously 6 minus 3y equals 18. So now I just need to solve this as normal. So I would actually add the 3y across just to make it positive. You can do it in fewer steps than this, but I'm kind of over-explaining. Take away the 18, so they basically swap, don't they? The 3y and the 18. So negative 12 is positive 3y, divide by 3, we get negative 4. You might have solved it differently, but as long as you get x is 3 and y is negative 4, then that's fine. And that is 4 marks. Question 11. Triangle A is translated by the vector 6, negative 4 to give triangle B. Triangle B is rotated 90 degrees clockwise about the point 1, 2 to give triangle C. Describe fully the single transformation that maps triangle A onto triangle C. So I'd probably draw this out actually, just so I can visualize it better. So translated by the vector 6, negative 4, that means 6 to the right and down by 4. So it will face the same way, but it's just moved. So 6 across, 1, 2, 3, 4, 5, 6, and then down by 4, 1, 2, 3, 4. So that's that bottom corner. And then from there I know it's 2 tall, 1 across, and I can plot that. So that is now triangle B, but then don't forget that it is then transformed again. So this one is then rotated 90 degrees clockwise, which is this direction, clockwise about the point 1, 2. So 1, 2, make sure you plot that one correctly as well. 1, 2 is here to give triangle C. Now I would recommend using your tracing paper. I don't have digital tracing paper, so I'm just going to figure it out myself. But I would use tracing paper. Stick your pen or your compass or whatever on this point and obviously trace around the triangle. So it's going 90 degrees effectively to the right. So the way that I do it without tracing paper is I kind of just plot again just one corner. So currently it's 3 across to the right, 2 down to that top corner. Now a 90 degrees rotation would go, instead of 3 across to the right, it would go 3 down, and instead of 2 down it would go 2 to the left. So I now know that that corner is here, the top corner, and just from visualizing it I can see that it would turn this way. So that is where triangle C is. Now we have to describe fully the single transformation that maps A onto C. So it's obviously rotated, hasn't it? We can clearly see that. It's not changed size or anything. It's not been literally translated. It's been rotated because it's now on its side. So I would say a rotation, and you can see it's 3 marks, so we're going to have to give some information. It's only one type of transformation, so the type is a rotation. But being 3 marks, I need to mention more details about it to get all of those marks. Normally with rotation, we obviously have to then say by how many degrees. So you can see from A to C, that's gone still in this direction, isn't it? The same. 90 degrees. And when it's 90 degrees, you do have to mention clockwise or anti-clockwise, so it is also clockwise. If it's 180 degrees, you don't have to mention clockwise or anti-clockwise because 180 would be the same either way. So that's one other detail. The final piece of information we need is the center of rotation, or the point where you're rotating it around. Now you might be able to figure it out, or also if you've got tracing paper, you could test it out. But the center of rotation is here. -4, 1. So now I've got 3 pieces of information for the 3 marks. Question 12. Here are some graphs. You can see we've got 9. Write down the letter of the graph that could have the equation, and I've just copied them over here so you can see. The first one is y is equal to x squared minus 4. Then we've got y is equal to negative x cubed, and then y is equal to negative 5 over x. So these will always be from the types of graphs that you're supposed to recognize. So the first one, hopefully you can recognize, is a quadratic. The highest power of x is x squared, so it's a quadratic. The next one is a cubic, because the highest power of x is x cubed, but technically it's a negative cubic, so it's a little bit more specific. And the last one is a reciprocal, but also a negative reciprocal. So now let's have a look. This one was a positive quadratic, and we should know that quadratics normally have a U shape, or an upside down kind of N shape if it's negative. But that one's not negative, is it? You can see it's positive. So the ones that are U shape here are A and H. But A is upside down. This one's a negative quadratic, so it can't be A, so that one must be H. So we've crossed out these ones. The next one we just said is a cubic, but also a negative cubic. Cubics normally look either a little bit like this, or maybe up and down, or being negative, it's the other way around. So have a look, which ones look like cubics? We've got C, we've got E, and we've got F. Those are all cubic graphs. But it's a negative cubic. As I've just said, it goes from the top downwards. So C and E are both positive cubics, so not these two. So I would say for this one, it's F. And lastly, for our reciprocal graph, normally it looks a bit like this, but it's a negative, which means the quadrants will swap, so it looks a little bit like this. So here we've got 2 reciprocal graphs, B and J. We need to have specifically the negative one, so that is J. D and G are just both straight line graphs, so as we mentioned in the other questions, it will be y equals mx plus c, that style of equation. So not these ones either. So we've got H, F, and J, and that's 3 marks. Question 13. The table gives information about the amount of time that each of 150 people were in a shop. So you can see it's a frequency table. On the grid, draw a histogram for this information. So hopefully you know for histograms, you will have the class interval along the bottom, so that will be the time in this case. And then vertically, you will have the frequency density, which as you can see is not currently a part of our table. So you might want to make another column for frequency density because we're going to have to work it out. So for histograms, this is the formula triangle, frequency at the top, frequency density, and class width at the bottom. We're trying to find out the frequency density. So can you see how it's frequency, which is this column, divided by the class width, which is the left-hand column. So for the first one, I have to do 20 divided by 10 because the width is 10. 20 divided by 10 is obviously 2. The second one is 70 divided by 20 because you see how the difference between 30 and 10 is 20. So 70 divided by 20 is 3.5. 22 divided by 5, we should get 4.4. 30 divided by 15 is obviously 2, and then 8 divided by 10 is 0.8. Now we obviously have to make sure that the scale on the vertical side matches and fits all of these. So how many big boxes do we have? 1, 2, 3, 4, 5. So what I'm thinking is maybe each box could be 1. So 1, 2, 3, 4, and 5, because we don't have anything bigger than 5, so that will all fit, won't it? And then across horizontally, we need to fill out this table. So again, it goes from 0 to 60, so we've got 1, 2, 3, 4, 5, 6 boxes. So I would say every box in this case is then 10. Now we can use our ruler to plot the information. So the first one is 10 across and 2 up. And just do effectively similar to a bar chart. Then the second one is 20 across, so from 10 to 30 and 3.5 up. Then from 30 to 35 and 4.4 up. 35 to 50 2 up, and finally 50 to 60 at 0.8. So there's our histogram. So we've filled out the histogram, but we do actually need to make sure that both axes are labelled. We've obviously put frequency density here, but then we do need to write a label for the x-axis, which is the same as what was on the table. So the time, and then put in minutes, so they know what you're referring to. So we've got the axes labelled, and we filled out the actual histogram. Part B, work out an estimate for the fraction of these 150 people who were in the shop for between 20 and 40 minutes. So 20 to 40 minutes actually covers 3 of these bars. So one of them is a whole bar, so that's easy because we already have the frequency for it, but the other 2 we need to work out. So it's an estimate because we don't actually know where these people were, let's say between 10 and 30 minutes, but we can assume that, do you see how 20 is exactly halfway through the bar? So I'm going to assume that the amount we want is exactly half of this frequency. So from the table, the frequency for that bar was 70. So I'm going to assume the bit that I want is half of that, which is 35 people. This bar here is complete. We're including all of it, so that's 22 people. And then the 35 to 40 minutes bar, we've got, can you see how that's a third? We've got 5 minutes out of 15 minutes. So again, I'm going to assume it's just directly a third of whatever's between 35 and 50. So a third of 30 would be 10. So my assumption is that's 10. Obviously that's an estimate, isn't it? Because we don't actually know the spread of those people between 35 and 50, but we're just estimating. So we've got 35 plus 22 plus 10. Which gives me 67 people, but remember that they asked for a fraction, so out of 150, it's 67. And that is 5 marks in total. Question 14, expand and simplify 3x minus 1 multiplied by 2x plus 3 multiplied by x minus 5. So I like to expand the first 2 brackets first, and then we'll deal with the last one at the end. So 3x minus 1 multiplied by 2x plus 3. Expand that and simplify it as well. So 6x squared plus 9x minus 2x minus 3. And when I simplify that, I get 6x squared plus 7x minus 3. Bring back my last bracket that's missing, x minus 5. Then I like to expand it left to right. So the 6x squared, I'm going to multiply by both terms in that bracket there. So 6x squared times by x, and then 6x squared times by negative 5. So that's 6x cubed first, and then minus 30x squared. Then I move on to the 7x, so 7x times by x, and 7x times negative 5, so that's plus 7x squared, minus 35x, and then finally, negative 3 times by x, and negative 3 times negative 5. Negative 3x plus 15. I do it in that order just because then, when I collect my like terms, they're all next to each other, so it's just a little bit easier, I think. So minus 23x squared, minus 38x plus 15. So there's your final answer for 3 marks. Question 15, OAB is a sector of a circle with centre O and radius 6. The length of the arc AB is 5 pi centimetres. Work out in terms of pi the area of the sector. So we need to know those 2 formulas, the area of a sector and the arc length. The arc length is just pi times the diameter, or you might know it as 2 pi r, which I'll use in this case because we've got radius here. 2 pi r times by the fraction of the circle that it is, so the angle over 360. Now the angle is this bit here, that's the bit that we're missing. And then I know that that equals to 5 pi because I've got the answer, and I can put the radius in as well as 6. So what I'm going to do here is with the formula for the arc length and the answer for the arc length is I can rearrange it to find the angle because I do need that to work out the area. So I've got 12 pi multiplied by that fraction, so that becomes the numerator, doesn't it? Over 360 equals 5 pi. I can actually divide across by pi, I'll just cancel out the pi's because it's just 2 terms, they both have pi in them. 12 divided by 360, well if you do 12 divided by 36 would be 1/3, so it's 1 over 30, isn't it? So pi over 30, so I'm just going to simplify that fraction, but you can do it differently, is equal to 5. and then multiply across by 30. So theta, or the angle, is 150 degrees. So now I know what that is. The formula for the area of a sector is just the normal area of a circle, pi r squared, and then the same thing, multiplied by the fraction of the circle that we have. So I know the radius is 6, and I now know the angle is 150. So I can just work this out, obviously simplify it, but we don't need to work out the pi itself. 36 pi times by, this would simplify obviously, zeros would cancel. Divide both by 3, I get 5 over 12. And then you can work this out however you want. You can do 36 times 5 and then divide it by 12. What I would probably do is just divide by 12 first. 36 divided by 12 is 3. 3 times 5 is 15. So however you want to work it out, you don't have to do it exactly as I've just done in terms of the mental maths, but as long as you end up with 15 pi at the end, then that would be correct. Question 16. There are only n orange sweets and 1 white sweet in a bag. Syra takes at random a sweet from the bag and eats the sweet. She then takes at random another sweet from the bag and eats this sweet. Show that the probability that Syra eats 2 orange sweets is n-1 over n+1. So this is effectively, in my head, it's only 2 marks, but in my head this is effectively like a probability tree. So I might draw out a probability tree, or at least part of one, just so that I can visualize it, but you don't have to. We want to know the probability of eating 2 orange sweets, so both orange, so effectively you've got white and then orange. Because we're only interested in orange and orange again, I'm just going to draw this part of the tree, but technically it would carry on, wouldn't it, like that? But you don't have to draw all of it. So, what is the probability of picking an orange sweet the first time? The total sweets in the bag is the orange and the white, isn't it? So n+1. And then the chance of getting just an orange sweet would be n. So n out of n+1. Now, it does then change for the second one though, because do you see how they've said that she takes a sweet the first time, she eats it, so she can't replace it. She's not replaced it. So the second time that she tries to get a sweet from the bag, there are no longer n orange sweets because she's already eaten one. So it'd be n-1. And there's no longer n+1 sweets in the bag. Technically n+1 minus 1, isn't it? Which is just n. And then with probability trees, we always multiply across the branches, don't we? So effectively what I'm going to do is n over n+1 multiplied by n-1 over n. Now you could obviously multiply that. I wouldn't expand it because can you see how the n's should just cancel? And you can kind of see because you've got the answer there. So that gives me n-1 over n+1. That's how I would work it out. As I said, you don't have to draw the probability tree. I just find it easier so that I can mentally visualize it. And they give you your first mark for one of these 2 options here. And then your final mark for obviously showing that it multiplies. Question 17a. Rationalise the denominator of 1 over root 7. So when you've just got one term in the denominator, as in a surd, we have to multiply the top and the bottom of the fraction by that same surd. So in the numerator we get root 7, but the denominator would either be initially root 49, but you can just write it as, obviously that would square root, wouldn't it? That would become just 7. So for 1 mark you don't need to write the working out as such. So root 7 over 7. Part B, simplify root 80 minus root 5. Now when you're adding and subtracting surds, you have to have the same surd, as in not 80 and 5, because they're not the same, are they? So normally you're looking at simplifying one or both of them. Root 5 doesn't simplify, so I'm going to look at simplifying root 80. And because I know they have to both be a root 5 to subtract, I'm going to assume it's going to be something multiplied by 5. Now that something has to be a square number, which is actually 16. So that would square root to become 4 root 5, and then we're taking away the other root 5. So how many root 5s are there? That's technically 1 root 5, isn't it? That would be 3 root 5 left. It doesn't cancel out the root 5s. It just says that there's 1 less. So 3 root 5. That is 3 marks for all of that. Question 18. Show that 0.15 recurring plus 0.227 recurring can be written in the form m over 60, where m is an integer. So this is basically converting recurring decimals into fractions, but we've got 2 of them, and then we're going to add them at the end. So let's just go through the normal process for one of them. For x equal 0.15 recurring. Now I want to get another version of that exact same recurring decimal, so that would be multiplying by 100, wouldn't it? Because I need it to be in the same order. So that'd be 15 and then 0.15 recurring. So I'm going to use both of those. We want to subtract them, so maybe let me write the x again. Subtract them so that we cancel out the recurring decimal. So that's 99x equals 15, because this part should cancel out. And then solve it for x again. 15 over 99. Now, that would simplify, but I might leave it as that for now just to see where the other one goes. So the other one, you can use, I guess you could use x again, but let's use a different letter just in case. 2, 7, and the only recurring bit though is the second two digits, the 2 and the 7, not the first two. So this one's a little bit more difficult because we have to move the first two out of the decimal because I want to isolate just the recurring part. So I've isolated the recurring part, but then I need another version of that. So that would be again multiplying by 100. But we've already got 10y, so multiply 100 would be 1000y, and then that would be 227.27, so same order for my recurring decimal. Now, we subtracted that, didn't we? We want to subtract that again. Obviously, I'm going to subtract it the other way around. 990y. Obviously, these should cancel, and then don't forget that you do need to take away the 2. So that'd be 225. Obviously, divide across 225 divided by 990. Okay. I then want to add these together, don't I? Because they've told me to add them. But obviously when we add fractions, we have to have the same denominator. So I think what I might do here is the lowest common multiple, I guess I could just multiply this side by 10, couldn't I? And it'd be the same. So let's say 150 over 990. You might simplify it differently, that's fine. I might just do it this way. Add them together. 375 over 990. And then the only thing I need to do is if we come back and have a look at the question, do you see how their denominator is 66? So it's telling me that it will simplify further. And I just need to get to something with the denominator of 66. So I'm trying to think of quite big numbers. Obviously they both divide by 5, but it might take me a bit long if I use 5. So I'm thinking maybe 25. I don't know, you can simplify it however you want. So I'm thinking 25 goes in, but 25 doesn't go into the bottom one. 15 would go into the bottom one. So when I divide by 15, I get 25. And when I divide this one by 15, it goes into 96 times, so that into 900 would be 60 and then 66. There we go. So however you want to simplify it, that doesn't really matter, as long as you get down to 25 over 66. That was only 3 marks actually. And just to mention, the other way you could do it is you could add these two together and then just work out one recurring decimal into a fraction. That would also work. So it's up to you which makes more sense. Question 19, ABC and DAB are similar isosceles triangles. We've been told that AB is equal to AC, here and here, and then AD is equal to BD. So this one is the same as this whole one here. Then we've got a ratio, BC to CD is 4 to 21. BC, CD, so that's 4 and that's 21. Those aren't measurements, those are just the scale, but I like to write it down anyway. Find the ratio of AB to AD. So this side is comparable to AD, and AC is comparable to BD. So therefore, technically, BC is comparable to AB. So the whole of BD would be 25. Again, not in a literal measurement sense, but in terms of the scale of the ratio. BD would be 25 because you add those two together. And then because we've got an isosceles triangle, BD is the same as AD, isn't it? So that's also 25. And then if we have a look at the green lines and then the orange lines, BC out of AB should be the same scale, same fraction, as the smaller one, which is AB, out of the bigger one, which is AD. We know that BC is 4, and we know that AD is 25. And then I would solve this for AB maybe. So if we cross multiply, we've got 4 times 25, which is 100. And then that's AB squared, isn't it? If I square root that, AB in terms of a scale is 10. And now have a look. We've got the ratio of AB to AD. Well, I know that AB is 10, AD is 25. So that's 10 to 25. But obviously if we simplify it, that would be 2 to 5. Now there's loads of different ways to do that one, so if you get 2 to 5 then that's fine. That's just the way that made sense to me. It might be different for you. Question 20. 2 to the power of x is the same as 2 to the power of n over the cube root of 2, and 2 to the power of y is the same thing as root 2 to the power of 5. They've told us that x plus y is 8, we need to work out the value of n. So you might not know where to start here, but what I'd probably do is look at them both individually, and I would try to get the right-hand side of each equation more simplified. So you see how we've got 2 coming twice here. I would try and simplify that down to just once. So 2 to the power of x, just leave that there. First of all, hopefully you remember that the cube root can be written as a power, which is 1/3. And then if you think about your index laws, divide means subtract when you have the same base number, which is 2, isn't it? So that would simplify to 2 to the power of n minus 1/3. Do you see how now I've got just 2 to the power of something and 2 to the power of something else on both sides? So that means that x must equal n minus 1/3. And then do the same on the other one. 2 to the power of y. The square root is also a fraction, a half, and then to the power of 5. When you have these brackets, you're multiplying the powers, aren't you? That's also index laws. So that would be 2 to the power of 5 over 2, or 2.5 if you prefer. So again, we've got that same scenario. 2 to the power of something is equal to 2 to the power of something else. So y must be 5 over 2. Now, we haven't used this information here. X plus y equals 8. So x plus y, well, I know that y is actually 5 over 2, or 2.5, equals 8. If I take that away, you get 5.5, or 11 over 2 if you prefer as a fraction. And then I can just substitute it back in here. So 5.5 is equal to n minus 1/3. Now, as I said, you might actually prefer that as a fraction now. 11 over 2. I want to add that across, don't I? So 11 over 2 plus 1/3, we need a common denominator, which would be 6. So times that one by 3 would be 33 over 6, plus times that one by 2, 2 over 6, equals n. So n would be 35 over 6. Now, they will also allow if you put it as a mixed number as well, which is 5 and 5/6. Either of those answers is fine, or equivalent. So that's for 3 marks. Question 21. A solid cuboid has a volume of 300 centimeters cubed. The cuboid has a total surface area of 370 centimeters squared. The length of the cuboid is 20 centimeters. The width of the cuboid is greater than the height of the cuboid. Work out the height of the cuboid. So I'd probably create an equation for volume, maybe to start with. So the volume of a cuboid, you would do the length times the width times the height, wouldn't you? So length we know is 20. Times the width, which I don't know, so maybe put w, or you could put x if you want. And then times by the height, which I also don't know, you could use h or y, is equal to 300. Now what we could do is simplify that if you like, just for now. Divide by 20, so that would be 15. So we now know that the width times the height is 15. Now, let's use this total surface area. How would I work out the surface area of a cuboid? I would do the length times the width. I might actually prefer to draw it out. So draw a rough cuboid if you want to imagine it. Call that one the length, that one the width, and that one the height. I would do the height times the width, and there would be 2 of those, wouldn't there? So that would be 2wh, let's put it that way around, plus, then this side would be the h times the l, which is also 2 of those, plus 2 of the top and the bottom, which is w times l. And that equals to 370. And now remember, I do know what the length is, so I could sub that in. Okay, let's work that out. So that's 2wh plus 40h plus 40w equals 370. Also remember, we know what wh is, so we could sub that in as well. That's 2 times 15 plus the 40h plus 40w is 370, so that I know is obviously makes 30. I could move the 30 across, so 40h plus 40w equals 340. We could divide everything by 10 at least, so 4h plus 4w equals 34, and then we could at least half everything, so 2h plus 2w equals 17. You can work this out however you want. You could also divide that by 2 as well if you wanted, so h plus w is 8.5. And now if you have a look, we've got simultaneous equations. So we have WH is 15, and if I rearrange the other formula to make W the subject, I can then maybe substitute it in and be left with only H, because ultimately I am only looking for the height. So making W the subject, I just have to take away the H, move it across, so 8.5 minus H. And instead, let's put the height first, so H first, multiplied by effectively this bracket, 8.5 minus the height, which is the same as the width, is equal to 15. And I just have to solve this. If I expand this out, you will see it's actually going to give me a quadratic equation, h squared, or even at that, a negative quadratic equation. So to solve quadratics, especially without a calculator, I want to move all of the terms to one side. My preference is to make sure that the squared term is positive. So in this case, I would move everything to the right and then factorize. So let's say I get left with 0 on the left. I would have to add the h squared to make it positive and take away 8.5h. And obviously the 15 is still there, so that's positive. Now, I don't really want to factorize it if it's got a decimal, so what I would do is just multiply the whole equation by 2. So I actually end up with 2h squared minus 17h, now it's a whole number, plus 30, remember to multiply everything, and I can actually look at factorizing it. So I would have 2h in one bracket, h in another. I need two negatives, 5 and 6. And solving it would give me h is positive 5 over 2, or 2.5, or the other option is 6. Now, you might be thinking, well, what's w? If you were just to quickly in your head substitute both of these values back in to this original equation, w is equal to 8.5 minus 2.5, that would give me 6. Or w is equal to 8.5 minus 6, it would give me 2.5. So what that tells me is we actually do already have one as the height, one as the width. Now the question only asked for the height, and it stated that the width of the cuboid was greater than the height of the cuboid, so I know the height has to be the smaller one. And technically the width would be 6. But they've only asked for the height, so I will leave it as 2.5 centimetres. And as you can see, that is 5 marks. Question 22, part A. Sketch the graph of y equals sine x for x being between 0 and 360. So we should know that sine x always starts at 0, 0. It then goes up to the highest at 1, so we could always write that there, 1. Comes back down. Every 90 degrees it kind of changes, doesn't it? It's up, down, down again to minus 1 at 270 and then back up. And it's this kind of smooth curve here. Something like that, that's not very good, but you get the gist. They just want a rough sketch of it. And you do have to label the 1 and minus 1 to get the second mark. Part B, solve the equation 2 sine x is equal to minus 1 for that same range. So what I would probably do is rearrange this to get sine x as the subject. So that would just mean dividing by 2. So we've got negative half. Now I'm going to use my graph here actually, just to give me an idea. We're looking at where y is negative a half because, if I come back, can you see how obviously that bit's sine x, this bit matches the sine x, and on the other side was y, it's now negative a half, or negative 0.5. So we're looking at where y is negative 0.5. Where is that? It's roughly here, isn't it? Roughly. Now that just gives me an idea as to, first of all, how many solutions there are. You can see there should be 2 because they've said between 0 and 360. So there are 2. And also roughly what they are. I know that one is above 180 and one is less than 360. Now the way that I actually figure out exactly what that would be, because it's not an estimate, is I should know what is sine x of positive a half, or positive 0.5 half. That's just from your table of values, the one they ask you to memorise. That's where x is 30, isn't it? 30 degrees. Now how do I relate that here? Well, that's actually then 30 degrees on from 180 plus 30. And then symmetrically 30 degrees back from 360. So those are my two solutions, 210 and 330. That's how I would figure it out. Now final question, question 23. C is a circle with centre 0, 0. L is a straight line. The circle C and the line L intersect at the points P and Q. So first of all, that's telling me it's not a tangent, right? Because a tangent would go straight across and it would only touch at one point. It's telling me it intersects twice. So I'm thinking, right, the line L must go through the circle somehow. The coordinates of P are 5, 10, and the x-coordinate of Q is -2. L has a positive gradient and crosses the y-axis at the point 0, k. Find the value of k. Okay, a lot going on here. Often I feel like I like to sketch it. We can try, we'll see how accurate we'll get. We can draw a little sketch here. So the circle has centre 0, 0. Let's say that's our circle. So then they've said the coordinates of P are 5, 10, so that must cross the circumference, right? So let's say 5 across 10 up, maybe about here, just roughly. So that's P, 5, 10. And it's a straight line with a positive gradient, so it must go kind of diagonally somewhere along here. We've said that the x-coordinate of Q is -2, so that's 5 across, so a little bit less. Obviously it's not accurate, but just a little bit. It's about here, isn't it? Q is -2, and I don't know what y is. Now if I draw my straight line there, because it doesn't cross through the centre, does it? It's not symmetrical. Okay, it's saying it has a positive gradient, and it crosses through the y-axis at k, so this here is k. That's what we're trying to find out. So I just find it helps to sketch it sometimes so I can visualize what's going on. Okay, so what I'm thinking is, I don't know the equation for either one, but I could work out the circle. Because the equation of a circle is always x squared plus y squared, if it's obviously a centre 0, 0, which it is, equals the radius squared. So I could work out the radius squared because I know a set of coordinates on the curve. So let's say that's the radius. I know, obviously from 0, 0, if we make that into a triangle, there we go, you can see that this side is 10 and this is 5, isn't it? So if you use Pythagoras, or you just sub it into the equation effectively, 5 squared plus 10 squared is the radius squared. Actually, I don't even need to work out the radius, I just need to know the radius squared. So that's 125. So you don't need to square root that because it won't square root, just leave it as 125, because then in my formula, my equation for the circle is x squared plus y squared equals 125. What I can then do is work out the y coordinate of Q, because Q is also on the circle, isn't it? So if I substitute in x is -2, that's where the point Q is, -2 squared plus y squared. Do you see how then I'm just left with y, or I could solve it to find y? That would be 4, so y squared would be 121, which hopefully you recognise is a square number. So that's then plus or minus 11, isn't it? If you square root, plus or minus 11. And we know, just because I've drawn it, we know that that should be a negative. Y is -11, isn't it? So now I know this coordinate. -2, -11 for Q. And once you've got two sets of coordinates on a straight line, you can just work out the equation of the straight line, can't you? So we need to know, obviously the equation of a straight line is y equals mx plus c. The whole point is we're trying to find the plus c, isn't it? That's where k is. So I need to find the gradient first, which is change in y over change in x. So it doesn't matter which set of coordinates you put first, as long as you put the same x and y matching set first. So if I start with 10, take away -11 would be then 5. You see how 10 and 5 are from the same set of coordinates? Take away -2, just be careful of any double negatives. So 21 over 7, which does simplify to 3, and as you can see it should be positive. So now I know I've got y equals 3x plus c. I need to find, obviously, the plus c. You do that by just substituting in any set of coordinates that are on the line. So you can either substitute in q or p. I would suggest p because it's just a little bit easier, isn't it? Just make sure you substitute them in correctly, that the 10 goes first, and then the 5. So that's 15. Take away 15 is -5. We knew it should be a negative number, and that is effectively k, isn't it? That's k, -5. So there's our answer. Obviously that's 5 marks. It's quite a lot of working. -5. Okay. So as you can see, that is the end of the paper. That's everything you need to know for the June 2024 Paper 1 Higher Tier Edexcel past paper. Thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.